Okay, good day everyone. So today I'll be teaching the differentiation from first principle, how to get the formula. Okay, so let's say we have a function or an equation y equal to f of x, right? And now let's say this function or this equation can be represented graphically as this. Right? Let's call this axis y, and then let's call this axis z. Right? Now, before I go further, one thing we need to take note of is this. At the first principle derivative formula, it tells us two things. Okay? The first thing it gives us, or the first information we get from this, is that the formula tells us the average rate of change of y, with respect to x, number one. And then the second thing it tells us is that it gives us the instantaneous rate of change of y with respect to x as well. So it tells us the average rate of change initially, and then as we saw further, it gives us the instantaneous rate of change of y with respect to x. Okay, so let's start with this one first of all. So the average rate of change of y with respect to x. Okay, now we know that to get the average, we need two or more points or two or more things to get the average of something, right? So in this case, to get the average rate of change of y with respect to x, we need two or more points, at least two or more points in this coordinate, in this graph rather. So let's call this point A, right? And then let's call this point B. And then a line connecting A and B is a secant line, right? And now we have another point because we're trying to get the average rate of change of y with respect to x first of all. Okay, so a line connecting A and then another point. Let's call this point C, right? So now each of these points have coordinates. So A is x1, y1, and then C is x2, y1. B is x2, y2, right? So these are the coordinates for the 3 points. So now to get the average, in other words, can be written as, or can be known as, the gradient, right? It can be represented as this m equal to increase in y all over the increase in x, right? Or y2 minus y1 all over x2 minus x1, or delta y all over delta x, or the rise all over the run. All of these mean the same thing. Okay, increase in y all over increase in x, or y2 minus y1 all over x2 minus x1, or delta y over delta x, or rise over run. They all mean the same thing, right? So now let's say x2 minus x1 is equal to delta x, right? But x2 cannot be equal to x1, because if x2 is equal to x1, then we cannot find our gradient, we cannot find our first principle formula, right? So x2 cannot be equal to x1. So making x2 subject formula from this equation, we have that x2 is equal to x1 plus delta x, right? Now we'll make use of this formula, right? So now let's write our initial equation, which is this, writing it in terms of x1 and then x2. So we have y1 equal to f of x1, and then we have y2 equal to f of x2, right? But x2 is equal to this, so we can write f of x1 plus delta x, right? Okay, so now substituting each of these into this equation, okay, so we have m is equal to y2 is f of x1 plus delta x all over minus rather f of x1, which is y1, all over x2, which is x1 plus delta x minus x1 as x1, right? So if we open up this bracket in the denominator, we have our formula as this: x1 plus delta x minus f of x1, right? This is over this will cancel at this, so we have delta x, right? So this is our gradient formula. This is the instantaneous, or the average rate of change rather, of y with respect to x. Average rate of change of y with respect to x, right? Now, in most textbooks or in most tutorials, they use h in place of delta x. It still means the same thing, okay? So if you replace delta x with h, this is what we'll get. We'll have this: m is equal to f of x1 plus h minus f of x1 all over h. These two formulas are the same. One is written in terms of delta x, and then the other is written in terms of h, right? So this is the first thing we need to know, so the average rate of change of y with respect to x, which is this, right? So now the next thing that we need to take note of, or that we need to solve for, is to get the instantaneous rate of change, which actually gives us the first principle derivative formula, okay? It gives us the actual formula of differentiation using first principle. So to get the instantaneous rate of change of y with respect to x, what we need to do is we introduce limits, okay? Now we're taking the limit of this equation, or this formula, or this average rate of change of y with respect to x, and by taking the limit, we're taking the limit of this formula as h approaches 0, okay? So second thing, instantaneous rate of change, right, of y with respect to x. Now by getting the instantaneous rate from the word instantaneous, that means at an instant, so we're getting the instantaneous rate of y with respect to x at a particular instant, at a particular point, and that point is at a, right? So we do that by taking the limit of our average rate of change, right, as h approaches 0, or as delta x approaches 0, whichever you choose, it still means the same thing. Limit of average rate of change of y with respect to x, right? So now by taking the limit of the average rate of change of y with respect to x, we get the instantaneous rate of change of y with respect to x. And so what we need to do is to substitute this formula, or this. Okay, let's use this. Let's stick with h. I'll substitute this formula into this equation, and then we have this limit as h approaches 0 is equal to, limit of this as h approaches 0 is f of x1 plus h minus f of x1, right, all over h, right? So this is the formula for the average, for the first principal derivative formula. This is the first principal derivative formula, right? This gives us the average, or the instantaneous rate of change of y with respect to x as h approaches 0, right? Thank you.